unified modeling language is a general-purpose, developmental modeling language in the field of software engineering that is intended to provide a standard way to visualize the design of system. The creation of UML was originally motivated by the desire to standardize the disparate notational system and approaches to software designs. It was developed by Grady Butch, Ivar Jacobson, and James Rambourg at Rational Softwares in 1994 to 1995, with further development led by them through 1996. In 1997, UML was adopted as standard by the Object Management Group and has been managed by this organization ever since. In 2005, UML was also published by the International Organization for Standardization as an approved ISO standard. Since then, the standard has been periodically revised to cover the latest version of UML.
Structural diagram captures static aspect or structure of a system. Represent the state of an object of the class. Are these descriptions of the structure or static features of a class? These are the structural diagrams are used. Class diagram. It is a building block of object-oriented software systems. The class diagram shows the system classes, their methods, and their attributes. Class diagrams also help us identify a relationship between different classes or objects. Class diagram can also be used for data modeling. Composite structure diagram represent the internal structure of a class and interaction points with other parts of the system. This composite structure diagram represents the relationship between parts and their configuration which determine the classifier, class, a component, or a deployment node behaves. They represent internal structure of a structured classifier, making the use of parts, ports, and connectors. Object diagram can be referred to as a screenshot of the instance in a system and the relationship between them. Component diagram are used to represent how the physical components in a system have been recognized. The deployment diagram represents system hardware and its software. It tells us what hardware components exist and what software components exist and software components run on them. Package diagram to predict how packages and their elements have been organized. A package diagram simply shows us the dependency between different packages and internal composition of packages. These diagrams are primarily used to organize class and use case diagrams. Behavioral diagram. Behavioral diagram visualize, specify, construct, and document the dynamic aspect of a system. Depict the elements of a system that are dependent on time and convey the dynamic concepts of the system and how they related to each other. These are the behavioral diagrams are used. Number 1. State machine diagrams. A state machine diagram is used to represent the condition of the system or part of the system at finite instance of time. It's a behavioral diagram and it represents the behavior using finite state transitions. State diagrams are also referred to as a state machines and state chart diagrams. These terms are often used interchangeable, so simplify a state diagram is used to model the dynamic behavior of a class in response to time and exchanging external stimuli. 2. Activity diagrams. We use activity diagrams to illustrate flow of control in the system. We can also use an activity diagram to refer to the state involved in the execution of a use case. We model sequential and concurrent activities using activity diagrams. So, we basically depict workflows visually using an activity diagram. An activity diagram focuses on condition of flow in the sequence in which happens. We describe or depict what causes a particular event using an activity diagram. 3. Use case diagrams. Use case diagrams are used to depict the functionality of a system of a part of a system. They are widely used to illustrate the functional requirements of the system and its interaction with external agents. A use case is basically a diagram representing different scenarios where the system can be used. A system use diagram gives us a high-level view of what the system or a part of the system does without going into implementation details. 4. Sequence diagram. A sequence diagram simplifies depicts interaction between objects in a sequential order, the order in which this interaction takes place. We can also use the terms event diagrams or event scenarios to refer to a sequence diagram. Sequence diagrams describe how and in what order the objects in a system function. These diagrams are widely used by businessmen and software developers to document and understand the requirements of new and existing systems. 5. Communication diagram. A communication diagram, known as collaboration diagram in UML 1.x, is used to show a sequence message exchange between objects. A communication diagram focuses primarily on objects and their relationship. We can represent similar information using sequence diagram. However, communication diagrams represent the objects and links in a free form. 6. Timing diagram. Timing diagram are a special form of sequence diagram which are used to depict the behavior of objects over a time frame. 7. Interaction overview diagram. An interaction overview diagram models a sequence of action and help us simplify complex interactions into simpler occurrences. It is a mixture of activity and sequence diagrams.
It's we to stay home, folks.
My heart's a stereo, it beats for you, so listen close. Hear my thoughts in every note. Make me your radio and turn me up when you feel low.
Turn it
This
up a little bit.
melody was meant for you. So sing